demonstrate Algebra 2. This is chapter 6.5. This is the third day of this, or third lesson of this. What we're going to do today is we're actually going to start to factor polynomials. We're going to factor these larger polynomials as f of x equals x cubed minus 3x squared minus 16x minus 12. And then they have k equals 6. What they're doing here is they're actually telling you one of the zeros or one of the factors that will be actually part of that polynomial. And so what we're going to do is we're just going to use synthetic division and say, if I put in 6 for synthetic division, I'm hoping, and I'm going to draw a little skeleton out here, we're hoping that if I put a 6 here, I will end up with a 0 here. That's what it's going to tell me. So if I do things right, I should end up with a 0 here when I plug in 6 there. Because k equals 6 is a 0 of this polynomial. It says, in directions, this is factor this polynomial. Given the fact that f of k, so maybe I should write that, where f of k equals 0. So when I put 6 into the equation, I'll get 0. That means it's a factor, it's a 0, and I can write it as a factor. So you got to demonstrate that you use this as a springboard. If I find a 0 from a degree of 3, the resulting polynomial will be a degree of 2, which then we can go to our other factoring techniques to factor. So this actually kind of turns out nice. Now, notice that this polynomial here does not need placeholders, right? So our coefficients would be 1, negative 3, negative 16, and negative 12. I'm going to shorten the box up. We don't need that large of a box. Right? We're going to put the 6 on the outside. And if we do it right, we should get 0. The next lesson, we're going to do the exact same thing, but it's not actually going to give us an answer. We're going to have to find them all ourselves. So we'll kind of take this in right now, that it's telling us what one of them are. We just have to find the rest. So using synthetic, first rule was drop the first one down, right? And then you multiply. 6 times 1 is 6.
3.
And then it becomes 3, and then it becomes 18, 2, and 6 times 2 is 12, and negative 12 plus 12 is 0. We were told that should happen, yes? So that means x equals 6, or in this case they put k there, I don't know why they use k, but x equals 6, or k equals 6, is a 0 of the function, or this polynomial. So, here's a really cool thing. Because this answer ends up being, remember, this is a constant. No, sorry, not constant. That's my remainder. Constant, x's, and x squareds. It becomes a quadratic, right? And so we can treat it as that. X squared plus 3x plus 2, and it'll equal 0 because that's the remainder. It equals 0. Because we're technically setting it or factoring it. Actually, take the plus 0, the equal 0 out of there. It just results in the fact that that's my polynomial. There's no remainder. There it is. But here's the thing. We took something out. What did we take out? We took out a 6. That 6 is still here. So what we need to do is we need to say, hey, I actually took out a 6. Now, why is it x minus 6? It's because of this. Because we said, or I said earlier, that x equals 6 was a solution, or a 0 to this. We have it k equals 6, but it's really, I put it in for x, right?
Yeah.
So when I put it in, x equals 6, it gave me a 0. This is a solution. We call that a 0. But I can take solutions or zeros and write them as factors. And to do that, I set it equal to 0, which means subtract 6 from both sides.
So what if it was negative first and equal positive?
Okay, so that's why that is here, okay? Now, your question of what happens if x equals a negative 4, right? That means I'd add 4 to both sides. This would be x plus 4 equals 0. And so x plus 4 would be the one in front.
So basically you're just putting x for k now?
Yes, I'm going to switch out. That's what you're going to do for your homework. Okay, I'm going to get this one out of here because that's not part of this. Now, it says you need to factor this. And now, since we got it back to a quadratic, I'm not going to use synthetic division. I can continue to use synthetic division, but then I'd have to guess and find some answers. It's a quadratic with a leading coefficient of 1. You know this first one, I'm not changing, but since it's a quadratic, won't it just break down to 2 different groups? Where it's going to be x and x, right? And then you say, what are the factors of 2? That'll give you a 3. 1 and 2. And the signs on those are?
Positive.
Both positive. You've now just factored the equation, or the polynomial. That's it. So let's try one here. We have a negative k value. So f of x equals 2x cubed plus 7x squared minus 33x minus 18. And k equals negative 6. We're going to do the exact same thing. We're going to factor the rest of it. So we make our upside down backwards L, put negative 6 on the outside. Do not need placeholders again. It's 2, 7, negative 33, and negative 18, correct? Going to drop down 2, and 2 times negative 6 should be a negative 12. Negative 12 plus 7, negative 5. Negative 6, you're adding, remember, we add going down.
You don't add going down.
Yes, you do. You subtracted in long division, you add in synthetic. Negative 6 times negative 5 is 30, which is negative 3. And negative negative makes it a positive 18, which is 0. Now, this particular quadratic, remember, we have x plus 6 now this time, right? Times 2x squared minus 5x minus 3. Because that's the resulting polynomial from our numbers here. That was here. Remember, x plus 6 comes from the fact that it would be x equals negative 6. We can write that over here. Was the solution, which meant I added 6 to both sides, so x plus 6 can equal 0. I found the factor there. Now this one, we have to use our techniques for finding the pairs or splitting it up so we can factor by grouping. So, off to the side, 2 times negative 3 is negative 6. Factors of negative 6, that'll give me a negative 5. Oh, not negative 1 and negative 6. Okay, so this would be a 2x squared. Let's just minus 6x plus x minus 3. And we're going to factor by grouping now.
Why would you do that?
Because the a value was not 1. We had something else here, so we had to break it up to factor by grouping. Parentheses around the first 2, last 2, including your signs. What can I pull out of the first group? A 2x and the x minus 3. Hey, x minus 3, that is what the second group is. So I don't want to pull anything out that's going to change it, so I'll pull out a positive 1. So that can stay x minus 3. So x minus 3 is common. I'm going to divide that out and push together the other pieces. And you have now just factored that inside part. here's the thing. We did not move or touch this. That needs to go along for the ride. Those three factors are my answers. The last piece to this is that one section says factor, the other section says find all of the zeros. And so, technically, this is one of your zeros. -6. You would state x equals -6. Now, for the others, there's two more. Those other two come from these factors down here. And to be zeros, all I need to do is say, hey, this thing is equal to 0, which means all three pieces are equal to 0, and solve them. So when does x minus 3 equal 0? When x equals 3, right? When does 2x plus 1 equal 0? Now that one you have to solve a little bit.
-1 divided.
Yep, -1. So you get 2x equals -1, -1, and then divide by, so -1/2. There's 1, there's 2, there's 3. There should be 3 zeros. Why are there 3 zeros? Because our original problem was of degree 3. Your degree tells you how many zeros you will have.